Good evening, everyone. Today's session is on confusion metrics, and we will be using this confusion metric for different formulas, like for evaluating the model, and in different evaluation methods, how to calculate accuracy, how to calculate precision. So we will be taking some examples and then apply all these evaluation methods and then calculate F1 score. So let's begin with the session. So basically, the evaluation part comes into the picture when we have AI project cycle, and AI project cycle, the final phase, the stage last stage of AI project cycle is evaluation. So in evaluation phase, what we are going to do is, if we are evaluating the system, we are testing the system and checking out what is the accuracy of that particular model. And if the accuracy is less, we need to rework on algorithms, and we need to basically, whenever we check any system, we need to check it out whether it is giving a correct output or not. Right, right, like it is giving accurate results or not. Right. So how do we evaluate? So there are number of methods. Using those methods, we can find out the reliability of the system. We can find out the accuracy of the system. So we have already discussed this thing, what is a confusion matrix and how we derive this matrix. It is basically a recording of results, and that is based on the four conditions that we have acquired from the data, right? Like we have the predicted things and we have the outcomes. So in actual, what it happens, and in predicted, using the model, what was the result. So based on that, we basically record all these cases into a matrix that is called confusion matrix. It is very important to know that confusion matrix is not any metric system or evaluation metric to be used for evaluating the model. It is just an recording of results. We are not taking it as an evaluation metric. So these two terms are different things. They are not same, right? So we have already understood how we have calculated the true positive, how we have calculated, how we have basically recorded these terms. What are the values of true positive, what are the values of true negative, what are the what is false positive and what is false negative, right? So based on that, we basically have our confusion matrix, right? We record our results. So this is our basically confusion matrix talks about. Let me give you a quick recap on this. If we have reality, or we can call it as actual results which we are getting out when we are running the model, right? So these are the actual results that we are talking about. They may be treated as a reality, right? So suppose you have 0 or 1. It is 0 and this is 1. Again, here we have 1 and here we have the 0 value, right? So this is how, like, if the predictions are matching with the reality, so you will be getting what? True positive, right? And if our reality is not matching with the prediction, it is false positive, right? And then we have, if the reality matches, if the reality is yes, or you may say, if it is it may be possible sometimes it does not matches, like reality value is 1 and false and the prediction was 0, right? So it is not matching, so we are taking it as false negative. Whereas when both are matching, reality predicted no, and using prediction we have no also, right? So we, here the result we get is true negative, where both the variables, that is reality and predictions, are matching. So this is just a you may say recording of results. We are not getting anything out of it, right? So that's why we are using these values for evaluating our model. So we have already discussed this thing, like we have number of evaluation methods. The first method talks about your accuracy, where we are talking about all the correct predictions upon total number of all the cases. Like suppose you are taking true positive plus true negative, all the correct predictions I am taking in accuracy. What is my accuracy of the system? So that I am going to check it out using a evaluation matrix, that is accuracy, right? Whereas, and it is over your all the number of cases. So here we have total number of cases into 100%, right? Next matrix is the next evaluation matrix is precision. Precision basically only talks about all the positive values, right? So here we have this positive, this positive, and this positive. So we have true positive over all the positive ones. You have true positive plus false positive as well. Then we have recall. So recall may we basically whatever we have not, yes, we have not covered the false negative part. That's why we have calculate that factor using the recall evaluation metric. So here we are including the positive ones also plus the negative ones also. And how to calculate the F1 score? So basically F1 score talks about whenever we calculate the precision and recall, the multiplication of both of them would be giving your the upper part numerator, and the lower part denominator would be giving your addition part, precision plus recall. And into 2 is like this, because most of the students get confused. It is with numerator. No, it is not with numerator. It is 2 is multiplied with this particular result, right? You are not going to multiply 2 into precision into recall. No, your answer would be incorrect in that case. So what you have to do, you have to make a bracket, first solve this bracket, and then you can multiply with the value that is 2, right? Now your F1 score basically ranges from 0 to 1. Now if it tends to 1, that means your model is a excellent model. If it tends to 1 like 0.9 or 1, right? And if it tends to 0, your model performance would be poor. So according to the value of F1 score, you can easily find out the performance of your model. Now let's take some examples and let's solve these examples, how we are going to calculate using different metrics. So here the first part that we talk about, in schools a lot of times there is one case scenario, and in according to that case scenario we have the four conditions. So the same conditions: false positive, true positive, false negative, and true negative, right? So here we have the first part. In schools a lot of times it happens that there is no water to drink, right? At a few places cases of water shortage in schools are very common and prominent. Hence AI model is designed to predict if there is going to be a water shortage in the school in the near future or not. So we will be making a confusion matrix and checking out the reliability of the model, right? So we found that there are values that is true positive, these are the values which are false negative, these are the values which are again false positive, and these are the values that are related to true negative, right? So we know that what is the formula of accuracy, how we basically calculate true positive. True positive is basically TP when we are talking about the correct predictions, right? So accuracy basically tells you about the correct predictions. So correct predictions, true positive, true negative, upon you have the all number, you have total number of cases into 100. So we have calculated like true positive is 22 plus 118 divided by 22 plus all the factors, like all the cases, 22 plus 12 plus 47 plus 118. So this is how we are getting the accuracy part of a model. Now we are just getting the percentage. It is a 70% accurate model. If we want to work upon some data set, we may do so. If we want to change the algorithm, we can do so, but it is giving you 70% accuracy. Most of the things is like you can change the data set, or you may use some evaluation method also, right? Like suppose you are segregating your training and testing data using some split method, you can use those methods, or you can use another method, that is cross validation, for checking this, right, for segregating the data set, right? Next thing is precision. Now precision only talks about the positive ones. Precision basically talks about the positive ones. So here we have true positive upon true positive plus false positive. We are not considering the negative values. We are only focusing on positive ones, right? So here we have 22 upon, that is true positive, upon 12 plus 22, right? So we are getting somehow 0.65. And in recall we are including the false negative part also, so we will be getting 0.3. So again I am repeating, we are not multiplying the 2 with the first numerator. We are going to have the full value, then we are going to multiply it. So our value, our model predicts the F1 score as 0.43, which is not a better, which is not giving a better performance, right? So we need to work upon that, because I told you the F1 score ranges from 0 to 1, and if it tends, it is less than 50%. It is less than 50%. So you need to rework on that and then check the accuracy. Let us take second scenario. Nowadays the problem of floods has worsened in some parts of the country. Not only does it damage the whole place, but it also forces people to move out of their homes and relocate. To address this issue, an AI model has been created which can predict if there is a chance of floods or not. So the confusion matrix for the same would be like this. You have to take all the four conditions, and the true negative and true positive part is also given. You have true positive, and this is the true negative. You have false positive, and you have false negative. So these four cases are already mentioned. Let us use this formula and calculate the accuracy of the system, right? So here we have zero values, right? There is no result that is matching with the actual and the predicted ones. We can easily find out this. If such kind of system exists, obviously that is going to fail, right? It is not going to provide you the accurate results. So what we are going to do is like TP plus TN upon, we are calculating the accuracy part upon total number of cases, that is F1, F1, FN, TN, FP and TP, right? So what we have done, like 94%, it is showing that accuracy was 94%. But when we have calculated the precision, recall and F1 score, it tends to 0. Might be possible it is giving you some error, some positive, because your true negatives are okay. But what about true positive ones? It is fail in this condition when your actual results are matching with the prediction ones. So one case is satisfied and one case is not satisfied. So this model is again going to be fail, and you need to rework on that, right? Again, taking a scenario 3, a lot of times people face the problem of sudden downpour. People wash clothes, put them out to dry, but due to unexpected rain, their works get wasted. So thus an AI model has been created which predicts if there will be rain or not. Right. So like in my previous session, I have explained like how we take out these four conditions. Is there is a forest fire or not? I have taken that case study and we have worked upon that. Right. We have calculated, we have basically recorded all the results like how to have our true positive ones and false positive ones, right? So here we have whether we have whether if will be rain or not. So in this case, we have taken another example in which the true positive, the result matches with the actual and predicted ones. The true positive is 5, and here we have is false positive 0, and true negative is when the result is matching is like this. So 5% of this. False positive and false negative again, it is 45. Like if you are checking it out, whenever we have some conditions, like it might be possible your accuracy is good, like in previous example 94% accuracy was there, in the previous example 70% accuracy was there, but as compared to the F1 score, when we are relying upon all the four conditions, whether it is giving the F1 score, the better F1 score, yes or no. If it is not giving, that system is going to, yes, not going to give you the accurate results. Right? It might be possible it is like it is successful, but it is not successful in all the conditions. So sooner or later it is going to be fail. So it's better to rework on these kinds of models, right? When we are getting such F1 score. So here also we are getting the accuracy 55%, right? And again we have calculated the precision, that is coming 1, and our recall will be 0.1. So let us calculate the F1 score. It is basically 0.1, which is not a good score, and it tends towards 0, right, rather than 1. It is tending towards what? The value 0. So obviously we need to rework on that and again change the data set. You may increase the data set, or you may say you need to change the algorithm. So it depends based on your problem statement what you are going to change. Either any of the attribute you might be changing, or some data set is irrelevant. It might be the problem like this, right? So if there is a problem, you can easily find out using your evaluation. In your evaluation phase, you can easily trace out that part, right? Now we have the last scenario. In this scenario, let us see, this is very important and interesting scenario. In this, traffic jams have become a common part of our lives nowadays. Living in an urban area means you have to face traffic each and every time you get out on the road. Mostly school students opt for buses to go to school. Many times the bus gets late due to such jams, and students are not able to reach their schools on time. Thus, an AI model is created to predict explicitly if there would be a traffic jam on their way to school or not. So, this would be like we are creating a confusion matrix for the same. Right. So, here our true positive when the result is matching is 50, and R again when the result is matching with the actual and predictions ones would be 0, right? So this is 0. And what about the other factors? You have false positive as 50 and false negative is also 0. So might be possible like when you have 50-50 kind of thing. So obviously your model is coming out of it as not a good model. It is giving you the accuracy which is again tends to 0 rather than it is a successful model. Let us calculate the accuracy. Obviously when we have in both the terms we have 50 here and we have 100 here, right? Because most of the we have FP and we have FP and TP, both are 50-50, and the same scenario with other two cases when we have false negative and true negative part, we have 0 in that, we have 0 in that part. So what we can do is we can have let us first of all calculate the accuracy part. True positive plus true negative, that is 50 plus 0 upon all the number of cases that you have 100, only 50 plus 50 and then 0 plus 0. So it would be giving you 50% accuracy. You can easily trace out from the confusion matrix. Rather than applying all the formulas, you can easily find out the performance of the models from the recording of these particular results. Then we have precision. Now in precision, you have taken out all the positive ones. Now your positive ones would be 50-50. So yes, the F1, your precision score would be good, like 0.5, but it is again tending towards, not tending towards 1, it is tending towards 0, right? 50% accuracy it is given actually. In recall, again you have true positive, and you are including the false negative part also, which is again a 0, so does not like adding a value, but obviously recall score is much good. Perfect fit, that is 1, right? So recall is 1. Why? Because the only thing is your true positive part is considered and true negative is Fn is 0. So that means your positive ones are good. Obviously only in the negative part you have the 0. Then in the F1 score, you calculate the precision and recall. Let us calculate it and we get the answer, that is 0.6. So 60% accuracy it is giving. Basically why we call it as like 0 to 1, if we have two systems 0 to 1. So it might be like it tends towards 0 rather than it tends towards 1. So it is in between. Even in that case, like we have seen in other examples, when we have such a big percentage of accuracy, 70%, 94%, and then 50%, 55%, and this is just 50%. Here the F1 score increases. How it increases? Because of we have the negative part that comes to a 0. So based on the different scenarios, you just come across this with this conclusion, like accuracy may not be giving you the actual scenario, actual analysis of results, until and unless you are not calculating the F1 score. So that's why whenever we use confusion matrix, whenever we calculate the confusion matrix, we have to calculate all the things, right? We have to use all the evaluation methods for checking the performance of the system, rather than focusing on only, like sometimes what we do is we are just checking the accuracy part. So yes, accuracy part is important, but at the same time F1 score is also important, right? So this is how, like, the different scenarios have different F1 score. Even you can see in the first scenario, even the accuracy was 70%, but your F1 score was lacking, that was 0.43. In the second scenario, you have the accuracy 94%, but again your F1 score was 0. 0 means very very bad, right? Then because have you seen in the explanation part, right? What is that? An ideal situation would be when we have a value of 1, that is 100% for both precision and recall. For both precision and recall. In that case, F1 score would also be an ideal 1, right? So it is known as perfect value for F1 score. So I told you, like, whenever we have a value that tends to 0, right? So that means your value would be like your model is going to be a bad model. It is not going to give you a perfect performance. And if it is a perfect fit model, then you have to use the 1 as your score. So that means whenever we are using the evaluation methods, the main thing that is kept in mind is your F1 score. Try to find out the F1 score rather than only calculating, like most of the, like I am doing the programming, sometimes what I used to do, I am only applying the accuracy part. But when you are using, I will be giving you some sessions on practical, like how to implement this thing, how to calculate the F1 score, how to calculate the precision, how to calculate the recall using Python programming. That would be more helpful in some scenarios. Like we can take any algorithm, we can take linear regression, we can take any other algorithm, and then we calculate the F1 score for that particular model. That would be giving you a best example, right? Because actual implementation is somehow like when you are able to run the program, and you can find out, like you can change the training or testing part, or you can change the percentage of both of them, right? But at the same time, when we are doing the practical using Python or using R programming, first we understand what are the basic concepts behind what is F1 score. Nowadays, I am finding like everybody is saying, my F1 score is coming out of this. But what is F1 score? How it is calculated? What is precision? What is recall? What is basically confusion metrics? So all these things would be coming under this part only. Until and unless you are not understanding the basic concepts behind any of the topic, you are not going to be like how you are going to implement it, right? Because Python is a, you may say, a robust language which is basically providing you each and every package and function also. Like confusion metrics, we can have a metric system, and you can call out those metrics for calculation of your accuracy, precision. You need not have to calculate this, but if you don't know what is how these values are coming, then how would you understand? So it's better, whenever we calculate any precision, whenever we calculate any recall, we should understand how it is calculated. So first of all, the base of all these methods is a confusion matrix, and before that confusion matrix, these are the four conditions from where this matrix is derived. So once you have derived these conditions, and I have explained you in my like you can refer to my previous session where I have explained you how these values are derived, how you get true part and how you get positive part, how you get negative part and how you get false part. So basically, I'm just giving an recap of that. False when the result is not matching, when your prediction and reality is not matching, then only you will get the false part. And when your result and when your prediction and when your reality is matching, that means you will be getting the true values. So true means when your result is, when your prediction and reality are matches. And when your prediction and reality are not matching, that means it would be a false value, right? And how you are getting positive and negative ones, that basically depends on the value of the prediction. If the prediction value is true, that means you can take it as positive. If your prediction value is false, that means you need to take it as negative, right? So once the first step is for any problem or scenario, first you need to calculate all these four steps, then make a confusion matrix, prepare this matrix, then apply the different formulas, and then get the F1 score. So your F1 score is going to tell you about the performance of the model. So basically these are the different evaluation methods which we are using in Python programming, and basically for any AI model, this is the evaluation methods, right? Hope you have understood, and like what are the concepts that are behind this. Hope you understand each and every concept and the scenarios which I have explained. Like accuracy does not matter, it matters, the actual thing that is matter is your F1 score, right? So hope you understand the session and like the session. Thank you.